Hello. Hello and welcome to this video. This is the sixth video on the examples of regular expressions. Before these six videos, we have covered the theory of regular expressions. So if you have not watched those videos, you should probably go ahead and watch those. So this particular example comes with a piece of warning that you should not probably use regular expressions like that. So the first example is about finding the regular balanced parenthesis. So you see in this test list, we have balanced parenthesis for three examples, the first, the second, and the fourth item in the list, while the third one is unbalanced. Now let's look at the regular expression and try to decipher it. So you see this caret followed by literal left parenthesis, and here at the end we have literal right parenthesis because these are escaped with a backslash. So what this means is the first and the last characters should be opening and closing parentheses. Now we see what is inside. We start with a non-capturing group. This question mark colon means it is non-capturing group. Now what could be inside is, if you look at this tells the character set allowed. So the character set allowed is anything except the parenthesis, and the plus means one or more characters. Or if this is not the case, what is allowed is another set of literal parentheses, and what could be inside is the same, basically, almost. That is non-parenthesis characters or another set of parentheses, or inside those parentheses there could be non-parenthesis characters. So that's the entire regular expression. Now see why this is wrong. The reason is that if you try to do something which is not matched by this parenthesis, or if there's an edge case you miss, it is problematic trying to debug this regex simply because it is hard to read. That is the truth about, or rather painful truth about regular expressions, is that they are kind of write-only stuff. Reading regular expression parentheses, especially complex ones, is a very painful stuff. And when you try to implement regex to handle complex logic, that is another big problem. Now that you have seen the regular expression and we have seen the test list, we will see that the first, second, and the fourth item will return true, and the third item will return false. So let's see this in action. I know I can run this within Studio Code, but I like the full screen terminal. So as expected, the first, second, and the fourth item did return true, while the third item returned false. Now let's comment this out. Not this. Okay. And let's look at the second example in picture. Okay. We'll take this also. So the second example is about validating whether a URL is correct or not. So I have three examples, and except the third one, the first two are good URLs. The third one is a bad URL. So it will return true for first two and false for third one. Now let's look at the regular expression. Now, if you look at the regular expression, it is valid for HTTPS and FTP URL. Now, what is allowed is HTTPS 0 or 1 times, or FTP colon slash slash. When I say slash, it means forward slash. When it is backward slash, I explicitly mention it. Now the forward slash, as you see, are escaped because that's a special character in regex syntax. So this will match up to here or up to here. After that, what is allowed is a non-capturing group. This signifies non-capturing group. So the first part is backslash capital S plus. That means non-white space characters plus another non-parenthesis group colon backslash S star. And this is optional. This part is optional, and that could come 0 or 1 time followed by at the rate. And the entire thing is also optional, that is 0 or 1. So what this backslash S plus is, it is the username, that is this part, and then the colon and the password. So colon and password. Now observe that entire thing is optional and password is also optional. Colon password is also optional. It is a valid URL in FTP. Now, I know some of you are from the uh, latest generation of programmers and might not have used FTP. You might have used stuff like FileZilla or PuTTY. FTP is old protocol, typically deprecated in favor of SCP for good reasons. But this is really valid URL. So now you see that since this entire thing is optional, this example is also correct. Now we come to what is after that. So again, if you look at this portion, this means it's a non-capturing group. After that, you look at this portion, it is a named match against IP. Now what the IP contains is, we have seen the exact regex of IP in the previous video. So if you have not watched it, you can go ahead and watch it. This is not a good example of capturing an IP. What it basically does is it takes a shortcut. Again, it's a non-capturing group. So it says backslash D 1 comma 3. That means it could be 1 to 3 digits followed by a dot. Okay. And this entire thing will be repeated 3 times. That is what this signifies. And at the end, again, there could be 1 to 3 digits. So that means it will match from 0 to 999 dot, 0 to 999 dot, 0 to 999 dot, 0 to 999. But we know that is not the correct range for IP addresses. So if you want the correct range, you can go ahead and watch my 5th video on regular expression where the correct regex is specified here. And the entire pattern is this. Okay. But it will work for this example. It will match the IP address. Okay. Now this could be one possibility. Now it is followed by OR. That is, if the IP is not matching, then we match the domain. And again, for the domain, the first thing is the non-capturing group. Now what the domain could consist of is A to Z, small letters and capital letters, and 0 to 9. So this is basically alphanumeric characters. And it can also contain hyphen. Now this is plus, means these could come 1 or more times followed by a dot. And this entire thing could come 1 or more times, which means there could be several layers of subdomains. And at the end, it will classify the extension part of the URL, for example, com or edu or some government extension. So that can consist only of alphabets and it should be at least 2 characters long. But comma 2 comma means it could be as long as possible. So that will contain up to this part. Okay, till now we have covered up to this part. Okay, after what follows after that? So what follows after that is basically the port number. For example, we can say this 443, the typical HTTPS port, and if you are running at some other port, for example 1443, which is usually not the case, then you can specify that also. So the port is filtered how? So this is the non-capturing group. This is the colon part of the port. Oops. Colon part of the port, and the port number can be from 2 digits to 5 digits. Now why 5 digits is basically because port numbers can be up to 65,300 something, that is 2 to the power 16 minus 1. So that's why 5 digits. I know that some port numbers, for example, you can specify 99999, which is not a valid port number, it will match the reject. So again, this is not a correct regular expression for the port number. Okay. Now, once we have the port number, we have the path. Okay, that is this portion. So as you can see, like all the parts, we have the non-capturing group, then a literal backslash. And then what follows is backslash s, negation of backslash s, which means any non-white space character can come 0 or more times. And also this is considered 1. Again, it is not a very accurate part of the URI. The reason is that certain characters are restricted in URI. For example, plus character is not really part of URL in general, those are encoded. So similarly, there are reserved set of characters in a URL what you should encode. Okay. Another example could be a percentage character that should be encoded. It should not be literally put in the URL. So again, I'll say these are approximations of what actual URL could look like. So IP address is not very correct, and then this is not very correct, and this is not very correct. But for a simple example, this works. So as you can see, I will run this and it will give us true for first two examples and false for the third example. So let's run this. And the expected output is there. Now we come to the third and the final example in this video. It is a mini JSON parser. It will extract the key value pairs at the outermost level. It will not parse a nested piece of stuff, but it will process the outermost layer. So we have this JSON mini JSON stuff, and how we parse it is we start the string with a double quote. So there goes our double quote. Followed by we have a named match with key. Okay, and what this key should be, there should not be double quotes in the key, and then there is plus. So this will match this name part, this will match the age part, this will even match Alice, not that, but we'll come to that. So name, age, and skills will be matched, and after that there will be double quotes. So it will match this double quote, it will match this double quote, and this double quote, followed by a colon. So it will match the colon and this colon and this colon. After that, there could be space because backslash s star is there. So 0 or more spaces are there. Then we have the value part. Now, what the value part contains is again double quotes. So this double quote, and so that is the only double quote. Or now we'll come to or. So this could come 0 or more times. Okay. And then it follows double quotes. So this Alice will be entirely mashed. Okay. And then double quotes. Or the other choice for the value is backslash d plus, which is basically a number, so 25. Now note that backslash d plus means arbitrary large number, but a JSON cannot have arbitrary large number. For example, since JSON is based on JavaScript, the integer is basically stored as a float. So what that essentially means is the maximum value, if I remember, is 2 to the power 53 minus 1. So any number, if you put larger than that, it will wrap around the range of minus 2 to the power 53 to 2 to the power 53 minus 1. So it will wrap around until it hits a value smaller than that, and that will be there. The second problem is that it does not specify negative numbers. So if we want to be more accurate, what we could do is we could put another pipe here oops, we could put another pipe and we can say minus backslash d plus. So that will represent negative numbers also. So that will match, okay? Because even if the JSON rotates, it will be a negative number or a positive number. So these two will match. Now the third choice which we have is basically an array. And in here we match only the brackets, the left bracket and the right bracket. And we don't care what is inside, we have put a dot star, which may be invalid JSON. Okay, so as like previous to example, it is not 100% JSON parser. It is an approximation of that. And the fourth one is something which can come inside braces. So for example, it could be like name and then we can have first. Oops. So what we could have is, it will work for something like this. Okay, so it will match everything inside that, but remember it is still value. Okay, this entire thing will be treated as value. So we'll see this and then we'll see that how this breaks stuff. So we run this, it gives us that. Okay, but here is a problem. It does not talk about what is inside that, or for example, it does not say that what is inside this array. We can type this, which is neither a string, nothing. It is in proper string, in proper everything, and it will match. You see, it matches. So as I said, it is not very correct. It is just an approximation of what a JSON parser could look like. So again, I will repeat the warning now that we have come to the end of video is that for complicated stuff, don't use regex. Plain and simple advice. Okay. It is not very good to read. I mean, if I see this in code, I'll simply not try to read it. Or if I see something like this, I'll try to avoid those portions of code. I wouldn't even want to modify it. And if a bug comes in the production or something, well, people will tear their hairs, pull their hair apart. Because as I said, nobody wants to read regex. It is heavily write-only stuff. So this I have repeated several times simply because it is so important. I have said this in previous video and before that. So with this we come to the end of regex and now I will show you where we stand. So we go to docs.python.org. We have covered regex in quite a bit of detail. So if I remember that we have done till regex, so we will go and start with difflib. Note that in the documentation, earlier documentation was 3.13 is what we have dealt with. Now with 3.14, this new stuff has come up. We will not study this right now unless we deal with the multi-threading feature. So I think the thread library will be there. Yeah, thread. Here we go. Once we cover this threading, we will come back and study this particular section, thread safety guarantees, not before that. So we will study difflib and it will take, I don't know, maybe 2 videos or maybe 1 to cover this. I will try to cover this in 1, but that will be a quite long video. So 2 videos, 1 for possibly theory and 1 for example. So I hope that you're enjoying this series of videos and finding it useful. And thanks a lot for watching the video. Happy programming.